RAMON Robot Automatic Spraying Marking Machine is mainly used for the marking of billet, round billet, and hot-rolled coils. Its main features include 1. Proper character size, adjustably and clearly. 2. Fast spraying marking. 3. Installation space can be reduced more than half compared with other conventional equipments. 4. Flexible spraying marking position. Marking can be done at different places. 5. Standard industrial robot is adopted with high stability and low maintenance. The system consists of 4 modules of robot platform, painting system, electronic control system, and safety guard device. The robot can be utilized for the repeat operation and under the harsh environments with high temperature, excessive dust, and danger. It can release the labor intensity, reduce the time of working under harsh environment, decrease the possibility of occupational disease. In some working procedures with high repeatability, the utilization of robot can make operation more stable and reliable, and eliminate some manually inevitable deviations and errors. Main technical index of system includes object temperature, 200 to 800 degrees Celsius. Special design is needed when beyond this temperature range. Environment temperature for installation, 0 to 60 degrees Celsius. Special design is needed when beyond this environment temperature range. Character size, 50 to 200 millimeters, adjustable. Spraying materials, water-based heat resistance paint. Average consumption of paint, 1 liter per 800 characters. The system has been successfully applied in large-scale steelmaking enterprises, such as Shagang Group, SISG, Day Special Steel, VIZAG, India, etc. RAMON Robot Labeling Machine is a new generation of character labeling equipment which utilizes a special printer to print various information such as character, logo, barcode, and two-dimensional code onto heat resistance label. By welding or nailing to fix label onto identified object, this machine can be widely used for the labeling of slab, round billet, billet, beam billet, and rolling products. Label is fixed with double nail to avoid the rotation of label, which is the advantages of stable fixing, good identification, and long storage. The extreme heat resistance reaches 1200 degrees Celsius. Matched with RAMON character recognition system, it can speedily realize the management and tracking of product online information, reduce the labor cost of material identification, avoid the identification error and metal lost, speed up inventory coordination, realize the full automation of steel production. Equipment working flow. 1. Printer prints label information and outputs after receiving the signal of casting blank in position. 2. Label positioning and punching. 3. Robot removes welded stud. Vacuum chuck sucks label. 4. Location detection of casting blank. 5. Labeling. RAMON High-Energy Beam Marking Machine adopts plasma power to control high-frequency oscillator to ignite the electric arc and generated high-energy beam arc by gas ionization. Then the PLC controls the high-energy beam writing gun to move an NC track and mark clear and permanent characters on the billet surface. RAMON High-Energy Beam Marking Machine is fit for slab, billet, round billet, rectangular billet in different size of cross-section. Characters. 1. Automatically marking with never peeling off characters. 2. Non-contact marking method without the influence of billet temperature, gradient, flatness, and oxide scale. 3. Adjustable character size according to the size of billet cross-section and marking character, customized from 30 to 100 millimeters. Marking step. The first step, the marking machine moves forward when the billet is in place. The second step, arc voltage lifting, drives the spray gun to working position. The third step, plasma power controls the spray gun for arcing and making. The last step, finish the marking, and return back for next billet. Most of steel plant adopts manual temperature measuring and sampling nowadays. Due different mold level height in each heat, the measurement gun always hits different relative location, which leads to unstable measurement results and is not good for the quality monitoring control during steel making. At the same time, production efficiency is also low by manual control. In order to solve these problems, RAMON developed robot temperature measuring and sampling system. Robot temperature measuring and sampling system is based on the platform of robot, utilizing the flexibility of robot to automatically install probe onto measuring gun, automatically insert into molten steel from the doorway of EAF or ladle mouth for temperature measuring and sampling, automatically dismantle the abandoned probe. The features of this system are high level of automation, easy operation, safe and reliable running. System working flow. 1. Oxygen and power supply inside. Furnace will be disconnected when oxygen consumption and power consumption inside furnace reaches target or system receives a command of start. 2. On the guide rail, robot moves to working position from waiting position. 3. Robot moves to the position of probe storage box. Gunhead is guided to insert by guiding device to realize the automatically installation of probe. 4. Combined with the detected molten steel, robot puts probe into molten steel for temperature measurement and sampling according to the set track. 5. Robot moves to probe disassembly position. Probe is disassembled by probe disassembly device. 6. Robot returns back to waiting position. 7. Temperature measuring and sampling is finished, waiting for the next heat. RAMON Robot Welding System is a new generation of automatic welding equipment developed by RAMON to improve welding efficiency, release labor intensity, realize automation of welding. According to customers' different application requirements, various standard and customized design can be provided. This system makes use of laser weld tracking system and self-adaptive adjustment function. It can real-time control welding gun's amplitude of swing, frequency, and moving speed online, which meets various welding demands. 1. With the feature of self-adaptive curve tracking. After teaching the welding start point and end point, the system can automatically track according to the path of welding seam. The robot automatically adjusts welding parameters, such as welding speed, amplitude, and frequency of swing, etc. With the enlargement of welding seam, welding speed and frequency of swing gradually slow down. Amplitude of swing is increased accordingly. 2. With the feature of self-adaptive tracking of bent welding seam. After teaching the start point and end point, laser sensor searches the welding position before welding. To automatically search position and plan welding start point, robot automatically adjusts the posture of welding gun according to the welding seam path. Recently, the first domestic robot automatic powder feeding system, which was developed and produced by RAMON, got a successful running in No. 3 continuous caster in No. 1 workshop of Hongfa Steel Plant of Sha Steel, with the accompaniment of Chairman Mr. Shen Wenrong and CEO Mr. Gong Sheng of Sha Steel Plant. General Director of Anshan Steel, Mr. Zhong Xiaoge, paid a visit to the Sha Steel workshop with several other high executives. They talked about the automatic power feeding system for nearly 20 minutes. The leaders were very satisfied with the effects automatic powder feeding system. The function of powder is to avoid secondary oxidation, get a better lubrication performance, absorb infusion, etc. in continuous casting process. The powder should be come into melting layer, center layer, and powder layer to ensure a better surface quality of products in continuous casting process. There are a lot of problems caused by manual powder feeding, which cannot guarantee a small amount of powder, and the operation cannot guarantee a small amount of powder, and the operation of powder, and the operation of frequent feeding. Meanwhile, the workers keep working in such a high-temperature environment with heavy labor intensity, which is the problem the leaders devote themselves to solving all the time. The maximum section of number 3 continuous caster is 320 by 2700 millimeters, which is the great challenge to automatic powder feeding.
反胚加扎系统主要是通过这个上位机控制和就地操作，按照这个设定的运动轨迹进行自动加扎。一方面减轻了工人的劳动强度，第二方面加扎更均匀，提高了这个产品的质量。
With the joint effort by RAMON Science and Technology Company Limited and Hongfa Steel Plant of Sha Steel, it took only 7 days to finish installation and test. Taking the on-site performance into consideration, this system is more reliable with self-contained facilities. Flexible ration powder feeding device can prevent particle powder from being pulverized to a certain extent. RAMON Robot Automatic Powder Feeding System has the advantages over the traditional automatic powder feeding device with its more reliable movement, less maintenance, programmable movement focus, and better flexibility. This product starts a new localization period of automatic technology for automatic powder feeding system with a high technological content and utility value. It signifies a new achievement obtained by RAMON on the road of self-dependent innovation. RAMON Laser Powder Thickness Measuring System has the capacity to detect the thickness of mold powder and forecast the powder feeding. It is realized by scanning measurement of protective powder through laser measuring meter and positioning device. Combining with molten level, system calculates out the real-time powder thickness. According to the detected powder thickness on each point, the system is able to forecast the feeding position and time. The measuring steps are listed as below. Firstly, the system locates to the electromagnetic mold level gauge position and measures out the distance between the 0 point of electromagnetic mold level gauge and laser measuring meter. Secondly, the system locates to the second position, where the laser measuring meter finishes scanning mold powder layer. And then, the system locates to the third position to do the scanning again. After finishing this measurement, the system returns back to the original position. RAMON Laser Powder Thickness Measuring System detects the powder thickness instead of human work. The system overcomes the disadvantages, such as huge manual operation, measuring error, unable of online and real-time measurement, etc. What's more, the measuring system has successfully realized the combination of RAMON Robot Powder Feeding System, which is more helpful to improve the powder feeding effect. With the guidance of RAMON Laser Powder Thickness Measuring System, it is achievable to feed the powder more evenly, reduce the probability of breakout accident, reduce waste of protective powder, and improve the billet quality. Converter lining thickness is measured quickly, accurately, and stably. Positioning, laser thickness gauge. Converter, the positioning of laser thickness gauge. Accurate positioning can be realized within 40 seconds. The measurement of converter rear wall lining. Converter rear wall lining can be accurately measured within 2 minutes. The measurement of converter bottom lining. Converter bottom lining can be accurately measured within 2 minutes. The measurement of converter front wall lining. Converter front wall lining can be accurately measured within 2 minutes. The measurement precision of system can be high up to ± 5 millimeters. Operator holds an industrial tablet. Standing in a certain distance from the front of slab stack, use a high-definition rear camera on tablet to take photos of sprayed characters on slab cross-sections. After the image pre-processing, characters positioning and segmentation. The characters are recognized, and then the results of recognition are being transmitted to the customer system by wireless network. System working flow. Operator holds an industrial tablet. Standing in front of slab stack. In case of dark situation, click button of light SW on the main interface to turn on LED light. Try to keep tablet at vertical direction in parallel with cross-section of stacks when taking photos. Adjusting the distance from slab stack so that the interface display window can display 4 pieces or 5 pieces of slab by one time. Then collect image from bottom to up in order. Click Recognize on main interface. After one stack has been finished, the recognition result will be displayed on the tablet, where the recognition results can be checked and revised. Click the screen of the tablet after finishing the whole stack recognition, so that the tablet returns back to image collection status for next stack recognition. Technology highlights. The system is simple, light and convenient to carry, easy operation, and convenient maintenance. The system won't be affected by the orientation of characters, with a strong capacity of disturbance resistance. Detailed historical data records, statements, and pictures are good for the tracking of slabs. Easy operation of human-computer interface can realize the automatic working by one click. No need of too much intervention. RAMON Optical Character Recognition System is the new technology achievement of RAMON's continuous development and application on the metallurgical field during the last 20 years. It includes RAMON image separation, neural network technology, which is capable of recognizing the sprayed characters. RAMON Character Recognition System adopts industrial computer to shoot the images of the sprayed characters on casting product. When the casting product moves to the area, a positioning sensor, optoelectronic switch, which will trigger the industrial computer to collect the images. The collected images will be sent to the IPC by Ethernet and pre-processed, positioned, segmented, and recognized finally. The recognized results will be shown on the main interface. Our system will transmit the recognized results to user system by industrial Ethernet. In the meantime, the system is capable of comparing the recognition results with the number which transmitted by the spraying machine. Automatically alarm if there is abnormal operation. Used for tracking and giving feedback that whether the sprayed characters are correct or not. This recognition system plays a significant role on steelmaking automation progress, which could improve the steel quality control, reduce labor cost, and raise working efficiency. RAMON Smart Cut-in Weight and Cut-in Length Control System is a revising system specialized in billet weight and length control. The system connects tightly length control in continuous casting and weight control in steel rolling. It is very helpful to improve percentage of continuous casting yield, decline remnant, and raise the benefits of steel enterprises. Features: 1. Online switch between cut-in length and cut-in weight. 2. Auto-inspect the cutting length. 3. Auto-manual complete weight measuring. 4. Auto-manual revise cut length. 5. Auto-control the stop of roller bed transmission. Working schedule of system. Step 1. After finishing the cut of billet, the roller bed starts to transmit billets to weighing area automatically or manually. Step 2. Inspection system controls billet to stop in weighing area. Step 3. Auto-manual complete weight measuring. Step 4. Complete fine adjustment of cut-in length by weight signal. Step 5. Wait to cut next billet automatically. Hand Steel, Shanxi Iron and Steel Group Company Limited. Hanzhong Steel. Cross-section 150 by 150 millimeters. Cutting length 6 meters, 9 meters, 12 meters. Control precision plus minus 3 kilograms. Wuhan Iron and Steel Group Corporation, Kunming Steel. Cross-section, 230 by 230 millimeters, 230 by 350 millimeters, 320 by 410 millimeters. Cutting length, 4.8 to 8.3 meters. Control precision, plus minus 3 kilograms for 230 by 230 millimeters, plus minus 5 kilograms for 230 by 350 millimeters. RAMON Surface Defect Inspection System is a technology independently researched and developed by RAMON, based on the adequate survey of production technology and process in continuous casting, aluminum manufacturer, and rolling mill. This system collects the real-time image of plate strip, steel and aluminum processes, detects and alarms during production, accurately monitors product quality to avoid loss. Features: 1. System can online discover and recognize defect and give an alarm to remind users to adjust production technology, avoid the increase of loss. 2. System can accurately locate the defects and provide defects coordinates so that the users can quickly find out and deal with the defects. 3. The labor intensity of defect searching can be reduced, labor time can be saved, production efficiency can be enhanced. 4. Claim for compensation caused by the quality defect can be avoided. Brand value is highly improved. Performance index, detection rate of defect, recognition rate of defect, detected defects type, dozens of defects, such as chromatic aberration, scratch, black stripe, impurity pressed in, crack and inclusions, etc. RAMON BOF Endpoint Control System is based on BOF steelmaking principle, photoelectric technology, machine vision, and digital image process technology, accurately predicting endpoint of BOF steelmaking. System working principle: through static model to calculate material balance and energy balance before steelmaking, oxygen flow amount and the feeding amount of cooling agent of that heat are tentatively confirmed to instruct blowing. At the late stage of steelmaking, the system rectifies dynamically the carbon content and temperature inside molten bath through continuously collecting the flame information at furnace mouth to realize the online prediction of carbon content and temperature inside the furnace. Starting dynamic model, accurately predicting steelmaking endpoint. System structure. System consists of mechanical seat structure, optical module, luminous intensity collection module, video collection module, digital process module, and industrial computer, etc. System advantages: 1. Detection design of double module of image information and luminous intensity information, and the processing of combination of static and dynamic model, plus high efficient and accurate algorithm. When the carbon content inside the furnace is less than or equal to 0.15%, carbon content prediction precision plus 0.02%, temperature prediction precision plus minus 20 degrees Celsius. The hit rate of both carbon content and temperature is more than 90%, which has great significance for saving energy and improving steel outputs and quality. 2. System adopts special optical process technology to realize the remote detection, avoid the use of tedious cooling device and dust removal device. The service life of equipment is long and maintenance is less. Site application: RAMON BOF Endpoint Control System has been applied in Jisco, Zenith, and Taishan steel. Following figure shows the curve of site temperature and carbon content change. Benefit analysis: endpoint hit rate of carbon content and temperature has been improved 50%. The loss caused by blowing is decreased. To calculate, according to the daily average loss on quality, $8 per ton, the annual increase benefit is $200,000. The smelting time each heat can be shortened 3 to 5 minutes. To calculate, according to 3 minutes, the daily steel outputs can be increased 3 heats on the premise of enough molten iron supply. The annual increased benefits is $1 million. The turning down frequency is reduced. The loss of metal and refractory materials are also reduced, and blowing frequency is reduced. To calculate, according to the average of $0.5 per ton, the annually increased benefit is $340,000.